For this problem, we are going to start with the graph of y equals x squared. Then we are going to do a number of modifications to the graph. We're going to have a number in front, we're going to have a number inside the parentheses, and then we'll have an added or subtracted number outside the parentheses. So we have three modifiers to the graph. Our goal here is to describe the changes that take place to x squared, and then draw the new function. I do want to point out that we are starting with x squared because this function has an x inside the parentheses and a square above the parentheses. Effectively, this is a heavily modified version of x squared. Now, our original x squared function does look like the picture. In this class, they will want you to memorize what this picture looks like for the purposes of doing transformations. For anybody who's new to this, I'm going to go ahead and give you the picture myself, but remember that it would help for you to memorize it. To begin, we'll start by writing down some points that are on this curve. This is because we need to know what the key points are on the curve before we try to transform them. We can see that the vertex of this graph is at 0, 0, which I'm marking with a red dot. We can also see that there are symmetric points on the left and the right. On the left, our point is negative 2, 4, and on the right, we have positive 2, 4. We'll write down those points now. With that in mind, now let's examine our transformations. With that in mind, let's have a look at our modifiers on the function. The x and the square, which I've boxed in blue, make up the base graph. Everything else will be a modifier. Notice the -1, which is after the function, will be a vertical shift. When you're dealing with a vertical shift, negative will move all of the y's down and positive will move all of the y's up. Because we have a -1 as our vertical shift, this means we will subtract 1 from all the y's. We also have a -2 in front of the parentheses. Since this -2 is multiplied, this will be a vertical stretch. Because of this -2 as our vertical stretch, all of our y's will get multiplied by -2. Finally, the +2 on the inside is our horizontal shift. If this horizontal shift is positive, this means all of our points will move left by this much. However, keep in mind that moving left by 2 means that all of our x's are going to get a -2 to them. Therefore, we'll subtract 2 from all the x's. If the +2 was -2 instead, this means we would move right by 2, and all of our x's would gain 2 instead. Therefore, now we know what our vertical stretch, our horizontal shift, and our vertical shift are. We know all the y's will be multiplied by -2, all of our x's will get a -2 because we're moving left by 2, and we're subtracting 1 from all the y's because of that vertical shift, -1. Now bear in mind that the horizontal shift in the order of operations comes first, then the vertical stretch, followed by the vertical shift. This will always be our order of operations for this sort of function. Let's write all of this down along with the points, and then we'll modify our graph. Here I've rewritten all of our points and our three modifications. We'll begin with the horizontal shift where we shift left by 2. When we shift left by 2, this means all of our x's will get a -2 attached. Our y's will not change in this step, only the x. Therefore, whatever y we had previously, we will still have now. However, all of the x's will be reduced by 2, so if we start with an x of 0, we'll go down to negative 2. If we had a negative 2 already, we'll go down to negative 4. And if we have positive 2, we'll go down to 0. These will be our new points at the end of step 1. Step 2 will multiply all of our y's by negative 2. However, this means our x's will not change in this step. The x's we had from the previous step will still be there. Negative 2, negative 4, and 0. When we multiply our y's by negative 2, the 0 we start with in the first point stays 0. The 4 changes to 4 times negative 2, which is negative 8. And the other 4 also likewise becomes negative 8. This is the end of step 2. Now we'll move to step 3. In step 3, we're shifting down by 1, and that means all of the y's will get a minus 1. This means the x's will not change in this step, only the y's. Our x of negative 2 stays negative 2, likewise with the negative 4 and the 0. However, all of the y's will go down by 1, so our first y of 0 changes to negative 1. Our next y changes to negative 9 because negative 8 minus 1 gives negative 9, and the same for the last y. Therefore, these will be our new points: 2, negative 1, negative 4, negative 9, and 0, negative 9. With that in mind, let's try drawing a picture. We'll start by plotting negative 2, comma, negative 1. Then we will plot negative 4, negative 9, so we will go 2 units to the left and down all the way to negative 9. We've made 9 marks on the y-axis, and we'll go down to negative 9 here and negative 4 on the x. We'll also plot 0, negative 9, which will be on the y-axis, but also at negative 9. Then we will draw a curve connecting those points. We'll also make sure that we add the arrows on the bottom to show that both the left and the right side will continue downward toward infinity. And so this is how we start with our original points on the original x squared graph and end with our new modified graph. However, the graph still has the same general curve shape.